chapter 4 is solution stoichiometry. We're back to stoichiometry. Now, if you remember in stoichiometry, we used the equation, and we took one compound, converted it to moles, ran it through the equation to find the other compound. So, for example, if we had A and we had moles of A, we can go to moles of B from the equation. Now, here is the difference from what we did before. And this only differs because we use molarity instead of molecular weight, formula weight, or atomic weight. So in some respects, I like solution stoichiometry better because it's faster, because I don't have to calculate molecular weights. Now, I can ask for one component in grams and one component in molarity. I can combine them, mix them up either way, because we know how to get from grams to moles to molarity, or from moles to grams, etc. But the beauty is if you're only working in molarity, you don't have to worry about calculating molecular weights. Okay, so some of you may have like deja vu all over again and like, wait, we've seen this equation before. Yes, we have. Let's real quick. We're going to pretend we haven't, and we're going to balance it. So one lead, 2 nitrates, 3 nitrates. Oh, so 2 and 3, we have to have a 6. So that's going to be 3, and that's going to be 2, which means this has to be 3 as well. So now our leads are equal. Our nitrates are equal. We have 3 sulfates, 2 aluminum. We're balanced. Okay. And so on this one, wait, I took all the fun out of it because I'm going to have to do math. Okay, how many grams of aluminum nitrate are produced when we always start with an amount? In this case, it's going to be 0.08954 liters of lead 2 nitrate is going to react with excess aluminum sulfate. So we're not worrying about a limiting reagent here. So we have this many milliliters of that. So we're trying to get from aluminum nitrate to aluminum sulfate, which means you have to go through the equation, which means we have to get to moles. Well, what relates moles to volume? Because this is in liters, molarity. So 1 liter of lead nitrate goes on the bottom, and 1.2 moles of lead nitrate goes on the top. So that allows us to cancel the liters and the nitrate. Okay, so we're left with moles of lead nitrate. So we know that we have lead nitrate moles on the bottom. But we need moles of aluminum sulfate on the top. So if we look at our equation, this is a 1. Where's lead nitrate? That's a 3. And we're asked for grams, so we're going to take 1 mole of aluminum sulfate. And we're going to find the molecular weight, 99624 grams of aluminum sulfate. Wait a minute. All right, I can't read. I write this down so that I can read, and I can't read. So I solved for the wrong thing. So I'm going to back it up to here because I solved for the wrong thing. This is what happens when you can't pay attention to what you're doing. That's why I write that out front so I can keep looking at it. So we have 3 moles of lead nitrate, and I'm looking for aluminum nitrate. So that's 2 moles of aluminum nitrate. So 1 mole of aluminum nitrate is equal to 212.99624 grams of aluminum nitrate. Okay, so when I do the math, everything on top is multiplied, everything on the bottom is divided. I get 15.2574 grams. If I look at it, then this is 4 significant figures, but this is only 2 significant figures. So that's the smallest. So with 2 significant figures, we get 15 grams. Okay. So if that had been 1.200, then it'd be 15.26. But, okay. So we're good on that one now. So this one says, how many milliliters of 0.05 molar aluminum sulfate were needed to produce 9.86 grams of lead sulfate? Okay, so we're looking for milliliters of aluminum sulfate. We'll start with an amount, which is 9.86 grams of lead sulfate. Got to calculate molecular weight on this sucker. If I go back and look, I probably have it. 303.2636 grams of lead sulfate per 1 mole of lead sulfate. And if we look at the equation, we have moles of lead sulfate. And this time I'm going to double check where I'm going. I'm going to moles of aluminum sulfate. So aluminum sulfate is 1, lead sulfate is 3. And so we've eliminated, we're down to moles of aluminum sulfate. But we don't want grams, we want milliliters. Well, do we have a conversion that relates moles to a volume? Yep. We have 0.53 moles of aluminum sulfate per 1 liter of aluminum sulfate. And remember, the number stays with the moles, and 1 liter is 1,000 milliliters. And why did I do that? Because I actually asked for milliliters. So that gives me a whopping 20.4484 liters. No, milliliters. So that means how many significant figures? We got 2, 3, 3, 2. So 2 significant figures. So it's 20 milliliters. Now, if I write 20 milliliters like that, that's only 1 significant figure unless I designate it. So if I put a decimal behind that 0, then it's 20 milliliters. So it's 2 significant figures. Okay? So on that one, I was looking forward to not having to do any molecular weights, but oh well. So let's look at this one here. This is solution stoichiometry, balance the equation, what volume is needed to react with that many milliliters. Okay, so on this one, it looks like I don't have any grams. Oh, I don't have any grams. So, wait, first thing I have to balance the equation. Oh yeah, forgot that. So 1 potassium, 1 potassium. Okay, 1 chlorine, 2 chlorines. So I have to have a 2 here. So that means I have to have a 2 here. So if I do that, then I have 2 potassiums, 2 potassiums, 2 chlorides, 2 chlorides. Now I have 2 nitrates and 2 nitrates, 1 mercury, 1 mercury. I'm good. Okay. So you're looking for the volume. Now I didn't specify, so let's make life easier. We could do it in liters of KCl. So we start with our amount, which is 0.1158. There's no zero, there's no decimal in there. So 58 liters of mercury 2 nitrate. Now, is it important to write the mercury 2 nitrate in there? Yes, because we're converting between two species, so we have to keep up with what we have. Well, we need liters to moles, which is molarity. So we have 0.64 moles of mercury 2 nitrate divided by 1 liter of mercury 2 nitrate. So we have eliminated our liters. Our moles of mercury 2 nitrate go on the bottom. And on top, we need moles of KCl. So I got to look at the equation. I have 2 moles of KCl, 1 mole of mercury 2 nitrate. So I've gotten rid of my moles of mercury 2 nitrate. I am at moles of KCl. Some of these grams. No. I'm asking for volume. So how do I get from moles to volume? Using molarity. So there are 0.25 moles KCl per every 1 liter of KCl. So I run my numbers and I get 0.592896 liters. If I'm looking at this, I see two significant figures. So it's 0.59 liters, which if you wanted to convert it to milliliters, since I didn't specify, it'd be 590 milliliters. You do not put the zero over the behind the zero. You don't put the decimal behind the zero because in this case you need that zero to not be significant. Okay, we need it to not be significant, so we are good to go. All right. So the next one is the limiting reagent problem. If 75 mils of 0.25 molar KCl is reacted with 9 mils, which is the limiting reagent? Okay, on this particular problem, I don't have a D part, so I'm not looking for a percent yield. Now, it doesn't mean I won't, but in this case, I don't, so I need to pick a product. All right, I'm going to pick, and it doesn't matter which one I pick, I'm going to pick the first one, which is KNO3 as my product. Okay, so what I'm going to do is I just need to go through the equation. I am not asking for amounts here. Really, the only thing I want to know is who's the limiting reagent. Well, if I only want the limiting reagent, I have to go through the equation. I have to go anywhere else. So the easiest thing to do is look for moles, because that gets me through the equation of KNO3. All right, so we're going to start with 0.075 milliliters of KCl, which means we're going to have excess mercury 2 nitrate when we run this one. So we have that many milliliters, we converted that to liters. Watch your units. So we know that there are 0.25 moles of KCl per 1 liter of KCl. And this is where we have to go through the equation. Moles of KCl to moles of KNO3 is 2 to 2. So at this point we have 0.01875 moles. And remember, we need to compare apples to apples. So we've got moles of potassium nitrate. So we're going to do it again. We're going to look for moles of potassium nitrate. But this time we're going to use our mercury 2 nitrate. So we have excess KCl. Do you have to write the excess KCl? No, but you have to understand that you have extra of it. So we have 0.0986 liters of mercury 2 nitrate. Okay, we have 0.64 moles of mercury 2 nitrate. for every 1 liter of mercury 2 nitrate. Now, I knew that went in the bottom so it could cancel. So moles of mercury 2 nitrate, 2 moles of potassium nitrate. Okay, I got 2 moles potassium nitrate to 1 mole of mercury 2 nitrate. And that gives us a whopping 0.12628 moles of potassium nitrate. Whoops. Okay, so at this point in time, the question is which one is the limiting reagent? Well, which gives you less? Well, this is the smaller amount of product. And again, this only works if you compare products and amounts to amounts. So we go back to our original reactant. So KCl is the limiting reagent because it runs out first. So notice that if you're just asked which one is the limiting reagent, you don't have to do anything more than go through the equation. So that's why I like molarity, because I didn't have to calculate a single molecular weight on this problem. Okay, I did on the previous. You can. But we're done. We're done with Chapter 4. Now, Chapter 3 and Chapter 4 are kind of the heart of principles. So this next test is very important that you not only know how to work the problems, but you show your work. Because for a problem like this, I might ask you for the final amount in that, and I may just make this a multiple choice, but it may be worth 6 points. But you only get all 6 points if you show me the work, and the work is right. And the way that also works is if you do the work, and you've done the work right, but you made a typo or something like that, so you end up picking the wrong species, then I can look at that and you get more points back than 0. Okay? So we are done with this chapter, and we are done with Chapter 4.